Good afternoon. This is Mohan Raj, Assistant Professor, Department of Mechanical Engineering, KSR College of Engineering. Today I am going to talk about the coordinate measuring machine, or it is called as CMM. This presentation is part of metrology and quality control course, and we will explore how a CMM is used to measure complex jobs with high precision. So a CMM is a precision measuring instrument used to check the size, form, shape, location and position of a workpiece. Instead of using traditional tools, a CMM uses a probe to touch different points on the surface and records their X, Y and Z coordinates. So X is for horizontal, Y is for vertical and Z is horizontal vertical coordinates, and these data allow us to build a highly accurate 3D representation of the component. So actually the modern components, especially in industries like aerospace or automotive, often have very complex shapes. So manually we are checking these with calipers and micrometers. It's actually slow and error prone. CMO makes it possible to inspect these intricate parts quickly with much greater accuracy. And the main functions of the CMM, actually it has four key functions. First, it has a mechanical setup with the 3-axis movement and a displacement transducer, and second, a probe head is used to touch or scan the part, and third one, there is a control unit that manages that movements, and finally a computer runs the software to calculate and displays the measurement results. CMM components, these main components are the mechanical setup, the probe system, control electronics and the software. So altogether these elements allow the machine to move smoothly, capture the data and produce a 3D measurement report. So this is the mechanical setup. This setup provides a rigid frame that allows motion along the X, Y and Z axis. To ensure the smooth and precision motion, some air bearings are used. These bearings are reducing friction and wear, allowing the probe to move quickly and accurately. So air bearing is working by creating a thin film of compressed air paths between surfaces. This means there is virtually no contact, so the movement is frictionless, and it also ensures that pressure is evenly distributed, which is critical for maintaining precisions. So these are all probes and probe head. This probe is that heart of the CMM. It is the part that actually touches the workpiece. The probe head holds and positions the probe. Different types of probes can be used depending upon the measurements, such as touch trigger probes for points measuring, or scanning probes for continuous surfaces. So to increase flexibility, the CMM have a probe changing system. This can be allowed the operator or machine to switch probes automatically to measure different features without stopping the process. Programming and measuring steps by using a CMM. So these are the steps followed. First, we home the machine to set a global coordinate system. Second, we qualify or calibrate the probe tip to account for its diameter. Third, we align the part and create a local coordinate system. Next, we measure the part by probing key points. So finally, the software transforms the data and presents the results in workpiece coordinates. So these are the types of CMMs. CMMs come in different designs. A moving bridge CMM is computer controlled and it is very common. A fixed bridge type offers high stability. Cantilever designs are always used for smaller manual operations, and for large parts, and we use a gantry type also. So these are the diagram for different types of CMMs. So this is cantilever CMM. So we know the word cantilever. One side is fixed, another side will be free. And this is the fixed bridge CMM. So both sides of the lever is fixed. So we can call it as fixed bridge. And it is a moving bridge in CMM. So the commonly we can say it as bridge type CMM. So one is fixed type and another one is moving type. So in this the bridge will be moving in a moving bridge. In fixed bridge CMM the bridge is fixed. And this is the gantry type. And measuring ranges depending upon the mission range can vary. For example, one mission might measure up to 460 by 460 by 300 millimeters, while larger ones can go over a meter in each direction. The size of the CMM is chosen based on the size of the parts being inspected. Potential sources of error, like any measuring system, a CMM can have errors. Spatial errors occur when measuring position of the point is inaccurate. Often, due to mechanical issues, computational errors happen when the software makes mistakes in calculating the dimensions or any other form. Factors affecting accuracy. Accuracy can be affected by several factors: the quality of the machine components like guide base and probes, environmental conditions such as temperature and vibrations, the probing strategy, and even the surface characteristics of the workpiece. The precision of the software and the computer also plays a vital role. So it also participating to affect the accuracy. To conclude, SEMM is a vital role for modern manufacturing. It provides fast, highly precise, three-dimensional measurement of complex components. By using CMMs, industries can ensure better quality control and reduce inspection time, which is critical in field like automotive, aerospace, and precision engineering. So, thank you so much.